Hello, welcome to Chapter 5, Section 2. We're going to be talking about energy today. So what we're going to do is we're going to identify several forms of energy. We're going to distinguish between potential and kinetic energy and classify these different types of potential energy. The rest of these goals have to do with practicing the math, which we'll do at a separate time. So first, what is energy? Energy is simply the ability to do work. So we can think of this in a couple different ways, right? We eat food. Food is how our bodies get energy so that we can lift things, move, think, and do everything that we do. So that is the way that our bodies get energy. We also use energy from things like dams here to power the things we use daily, like our computers and our iPods, or also to lift cars at a mechanic station so that they can work on them and other things like that. So energy actually has the same units as work. It's the joule. And there are several types of energy, and the kinds that we're going to talk about mainly are kinetic energy and potential energy. And within potential energy, we're going to talk about gravitational and elastic potential energy. So kinetic energy is just the energy of things in motion. When something is moving, like this person running and jumping here, okay, there's an energy associated with that. And we can calculate that energy because it depends on mass and velocity. And it can be found using this equation. Ke stands for kinetic energy, and it's just equal to 1/2 the mass times the velocity squared. We can also calculate the work done from kinetic energy, and this is called the work kinetic energy theorem, and we just use the equation where work is actually just the change in kinetic energy. Potential energy is a little bit different and trickier. Potential energy is the energy associated with an object because of its position or state. So we have gravitational potential energy and elastic potential energy that we're going to talk about. And these are both kinds of potential energy that depend on position. So where you're at changes your ability to have a potential for energy in the future, which means like the possibility. So this is like, you could think of this also as like possible energy. So let's look at gravitational potential energy first. So I'm going to abbreviate it GPE here, and it depends on an object's position above the surface of the Earth. And when it's above the surface of the Earth, the object has the potential or the possibility to fall. And if it falls, it would move and have velocity, and objects in motion have kinetic energy. So this is why it's potential energy, because it has the potential or the possibility to have kinetic energy, to move. And things like dams use potential energy to create energy because they hold all this water up here, so they raise water to a height by not letting it flow, right? And then they only allow the wet water they want to go through, and they use its kinetic energy to create electricity. So we can actually calculate the gravitational potential energy, and it depends on mass, the acceleration of gravity, so 9.81 here on Earth, and the height above the Earth. And we just write that mph. Also, I want to point out that your book, instead of writing GPE, they write PE and then a little g. So you may see gravitational potential energy described or shown in either one of those ways. The other kind of potential energy is elastic potential energy. And this is energy stored in an object when it stretches or compresses. So you can think of a rubber band, right? You can stretch out a rubber band, shoot it at somebody or not, and then it'll return to its original shape. Also, if you have one of those clicky pens, right, they've got a spring in them that stretches and compresses, and it always goes back to its shape. Okay? That ability to go back to its shape, to return what it was, that is a kind of potential energy, because after you compress it or stretch it and let go, it moves, which is a kind of kinetic energy, and returns to its original shape. So we can also calculate elastic potential energy. Okay, and we use the equation where elastic potential energy equals 1/2 kx squared. So K is something called the spring constant. We're going to be seeing that again and again. So make sure you connect that idea in your head. K is the spring constant. And that is just a constant that represents how stiff the spring is, or how well it stretches and returns to its shape. Is it easy to stretch? Is it difficult to stretch? X then, we're going to draw a little picture here. If you had a spring, here's my spring, and this is the non-stretched length of the spring. So it is this long to begin with. Then we might stretch the spring out until it's this long. That new length, the difference between its new length here and its original length here, is our X. So X is the stretched length of the spring. And it's really the difference, not the length. The stretched length. So when we're doing these equations, and we'll do an example a little later, you always need to remember to just measure the difference between the original length and the final length of the spring, because that is how we calculate elastic potential energy. Well, I hope you guys understand a little bit about what energy is and the types of energy that we'll be discussing and calculating in class. Please let me know if you have any questions.